On this 2015 to 2025 F150 with the 5.0 Coyote P0300 means the PCM has detected an engine misfire in multiple cylinders, or it cannot identify which cylinder is misfiring. The truck may run rough, stumble, feel down on power, or turn the light on only under certain operating conditions. Possible fault areas can include ignition, fuel delivery, air or vacuum leaks, EVAP or EGR influence, base engine integrity, cam or crank signal quality, oxygen sensor bias, poor fuel quality, low fuel level driving conditions, or recent work around rotating engine parts. Before clearing anything, record the captured misfire data, because clearing PCM codes erases that information. Also keep in mind that mechanical noise from accessory drive parts, mechanically driven fans, or rough road operation at high RPM with light load can confuse misfire detection. Start with the basic system checks and confirm P0300 is actually present. If the scan does not show the misfire code path, move into symptom-based diagnosis instead of forcing this routine. Once P0300 is confirmed, pull the PCM misfire freeze frame data and record the PID values. That data helps show the operating conditions that were present when the misfire was detected. Compare those recorded values against the normal reference values available to you. If something is already out of range there, follow a structured diagnostic approach for that system before going deeper into the misfire routine. If the captured data does not point you away, continue to mechanical contribution testing. Next, run a relative compression test using the scan tool process available for the vehicle. If that scan tool test is not available, treat it like a passing result and continue the flow. If all cylinders pass, keep going. If a cylinder does not pass, move to cylinder leakage testing on the suspected cylinder, and if leakage passes, run a compression test on that same cylinder. After that, check for other non-misfire continuous memory codes, then COYO codes, then COYER codes. If any of those are present, set P0300 aside for the moment and diagnose the other code path first. Do not stack assumptions on top of another unresolved fault. Now run the cylinder power balance test. If all cylinders are contributing correctly, move on to injector flow testing. If one or more cylinders are not contributing correctly, check the ignition system path next. When an ignition concern is found, repair it as needed, clear the PCM codes and repeat the self-test. If ignition is not the issue, continue to the relative injector flow test. If the injectors do not flow correctly, check for loose connections and damaged or corroded pins, repair as needed, and then continue into the fuel system checks. If the fuel system check finds a concern, repair it as needed, clear the codes, and repeat the self-test. If no fuel system concern is found, move to air and vacuum checks. Inspect the vacuum hoses for damage, deterioration, collapse, or restriction. A collapsed hose can restrict vacuum to an actuator or sensor, and some vacuum leaks can be heard. Also inspect the EVAP lines and hoses for incorrect connections or damage. If you find a concern, correct it as needed, clear the PCM codes, and repeat the self-test. If you reach an EGR branch in the diagnostic path, do not enter it by assumption. Pause, recheck the earlier path, and avoid guessing. When that path is legitimately reached, monitor the EGR-related PIDs with the engine at normal operating temperature, record the values at idle and with the engine off, and compare them to known good reference values. If the path calls for recreating the concern with the EGR disabled, use the captured conditions and customer information. Driving may be required. If the symptom cannot be recreated that way, inspect the EGR for contamination, unusual wear, carbon deposits, binding, or damage. Then repair as needed, clear codes, and repeat the self-test. If the vacuum and fuel paths do not find the issue, check base engine integrity. With the ignition off, evaluate the mechanical side in order. On vehicles with a mechanically driven cooling fan, rotate the fan by hand, check the accessory drive, run compression and cylinder leakage testing where needed. Evaluate valve train operation. Inspect the PCV valve and tube for leaks. And if equipped with intake manifold runner control, check the linkage for damage, disconnection, restriction, and full travel from open to closed. Engine temperature may affect these results, so keep that in mind when judging the test. If a base engine concern is present, repair it as needed, clear the PCM codes, and repeat the self-test. If no base engine concern is found on the P0300 path, continue toward the generator and crank signal checks. Before moving on, understand where the shared misfire routine can split. On a cylinder-specific path, the next check is to start the engine. Use the PCM injector disable controls, command the suspect injector off, and watch whether engine RPM changes. If the vehicle does not support those injector disable PIDs, follow the passing direction for that check. If RPM does not change on the suspect injector command, check that injector connector and pins for damage, corrosion, or an incorrect connection before making a repair decision. On a cam sync path, start the engine and monitor the sync PID. If there is a concern, a CMP sensor installed out of synchronization may set a code. Verify the installation, and if it checks out, continue with the rest of the misfire path. Start the engine and listen for generator electrical noise. Then turn the ignition off, disconnect the generator or regulator B+ connector, restart the engine, and determine whether the noise stays constant. If the noise drops when the B+ connector is disconnected, the generator or regulator may be electrically noisy, so diagnose that charging system noise concern. If the noise stays constant, move on. With the ignition off, visually inspect the CKP harness for damaged wires or other physical damage. Damaged CKP wiring can create an intermittent short in the CKP circuit. If you find damage, repair it as needed, clear codes, and repeat the self-test. If the harness looks good, inspect the crankshaft pulse wheel for damaged teeth, wobble, or looseness. Inspect the crank pulley for wobble, and check the CKP sensor for damage. If those parts are not okay, repair as needed. Check CKP sensor installation, reset KAM, and carry out the misfire monitor neutral profile correction procedure with the scan tool. If they are okay, continue to oxygen sensor bias checks. With the engine running, monitor the equivalence ratio and fuel trim PIDs for both banks, record the values, and compare any suspicious values against the reference values. Not every PID may be available on every vehicle. If the data points to a biased heated oxygen sensor concern, check the HO2's, the exhaust system, and the HO2's mounting flanges for leaks or damage. Repair as needed, clear the PCM codes, and repeat the self-test. If the oxygen sensor data does not show a concern, check the recent repair history. Look for recent work involving rotating engine parts such as the crankshaft, crank pulley, camshaft, flex plate or flywheel, pistons, connecting rods, or front-end accessory drive components. If that kind of work was done, carry out the misfire monitor neutral profile correction procedure with the scan tool. If there is no related repair history, the path moves into another structured diagnostic test, so do not guess at the next cause. Keep verification separate from testing. After a supported repair, clear the PCM DTCs and repeat the self-test. For final confirmation, recreate the original conditions that set P0300 or cause the symptom using the captured misfire data and customer information. Then monitor the cylinder misfire data in mode 6 on board test results and verify the misfire count is below 10. The takeaway is simple. Do not treat P0300 as just an ignition code. Work through contribution, fuel, air, base engine, signal quality, and learned misfire profile checks in order. For more diagnostic training, visit stepdiagnostics.com.